5%.
Nice. All right. So I'm Greg. Most of you know me. I technically do this for my day job, but I am officially off the clock. So this is not for my day job. It means I get to make stupid jokes, and you know, we're all friends here. This is just for fun.
Opinions are my own.
Yeah.
Opinions are my own.
You can heckle me, and I'll heckle back because I don't have to sell you something to do. This is an area that I've spent a lot of time in. We've had conversations before about like multi-cluster and like how do you solve some of these problems. When I was working at Walmart, this was basically the entire thing that our department did was solve multi-cluster hybrid Ingress global style things. We're gonna go through a few of the pieces. They're all like, most of them are built on open source things that are upstream. So it's not GKE specific, but GKE is the only implementation that I really actually know. So I'll try to point out the places that other people are doing similar things. But it's just cool stuff that I kind of wanted to get a better understanding about, because eventually I will have to do this for my day job. So this is a good kind of practice for us. So this is Kubernetes the easy way, right? You have one cluster. The world is your oyster. It's great. You have Ingress, you have services. Everything just works because that's what Kubernetes was designed to do. Definitely the happy path. And you can have multiple of these. If you have 25 different clusters, but they all live inside their own little world, it's great. You don't have any problems that you really need to solve. The bits and pieces that come with Kubernetes usually kind of solve that for you. Unfortunately, that's not always how things look. Like eventually you might get a second cluster. And you might have workloads that have to run in both clusters or have dependencies between them. Usually what ends up happening first is you'll just use DNS to kind of route between the two ingresses. But then you'll find one service that needs to talk to a backend in another cluster, and maybe you punch a hole with a load balancer. And you start getting these like bespoke, complex, and very fragile setups, right? This example, if you go from 2 clusters to like 12, kind of what Reddit was when I was leaving that company. It was very painful. I wish there was great solutions that we could have just dropped in place. At that time, I don't think that there really was, but recently there have been some developments, and I'm gonna go over what some of those look like now. But first, why, right? Like if you can live in one cluster, why won't you just stay there? Well, you don't always get a choice, right? You might have a service that is very latency sensitive. You have users in Germany, you have users in the US, you want those workloads to kind of be local, low latency. High availability. If you've ever used GKE, it is a regional service. There is no multi-region GKE, and there never will be. Google doesn't think that's the right approach. Others might. You might be able to get a managed Kubernetes experience that is multi-region, or you can always DIY. There's nothing that prevents you. But if you look into it and you spend any time with it, etcd going, raft around the world, probably not something you ever want to do. You're just making a really big fault domain that is eventually probably going to fail, and it's nicer to have these kind of regional failure domains. Data locality is actually a really big one. When we work with different customers, quite often they'll come to us and say, oh, we just signed a new account, they're in Europe, they mentioned the word GDPR, and now we need to build infrastructure in Europe. Right? They don't get a choice. They have to run their data locality. They have sovereignty that are required to go into that area. Most people actually do have multiple clusters, like test, dev, prod. They just don't have to manage a workload between all of them. But if as your company scales, you might have multiple teams. Maybe you have a data team, and they want to do things one way, and you have an infra team, they want to do it another way. You got a special team that wants to come in and change the world, and they want their own clusters and do things their own way. Well, now you're back in multi-cluster world. And a good one to point out is Kubernetes changes pretty rapidly. So what happens when you're going from 1.20 to 1.21, or you're upgrading your service mesh? You just run that on your production cluster. Like, that scares me. Not having 2 versions of a production cluster where I could make one change and my entire infrastructure stops working, that's incredibly scary. Having 2 production clusters, I can make a change in one and know I could revert to the other, makes me feel much, much better. So I'm not gonna go into too much. We're also not gonna cover other problems that come with multi-cluster. This is actually just hyper-focused on the networking side. We're we're gonna look at multi-cluster networking use cases. Have 2 production clusters, we wanna treat them like one. We wanna be able to route requests in through a single consistent IP. We want that low latency, shortest path, all the magic of that kind of global load balancing experience. But we also want to be able to do fun things with our traffic, like blue-green deploys or regional failover, around that kind of stuff. Maybe we want to have L7 load balancing, very common thing to do. What does that look like in a multi-cluster? Splitting, canaries, bursting, spillover. These are all things that you can do fairly well inside of a single cluster, but as soon as you move outside of one cluster, how can you get that same kind of experience? So we're going to talk about a few different things. I'm hoping most of you are familiar with north-south, which is usually for ingress from clients, say, from the internet, and then east-west, which is between services. So we're going to talk about multi-cluster services, which is an east-west mechanism of routing. We're going to talk about MultiClusterIngress, which is a north-south using a global public load balancer. We'll touch very briefly on ASM. It's a managed Istio service mesh, but some of the concerns around service mesh in a multi-cluster world. It came up today in Slack, so we're going to talk a little bit about gateway versus ingress resources. And then I didn't have a bunch of time, but ACM is one of the tools that I'll maybe briefly touch on how you can try to manage these workloads across multiple clusters. So to get started, we're going to talk about 2 key dependencies for these things. So the first is cluster native load balancing. In a DIY Kubernetes experience, and even on GKE, the original version, it was using sometimes called an overlay network, but it basically where pods existed inside of a network, and that network was only routable from inside of the cluster. That is no longer the case. GKE does use a VPC-native network for pods, meaning anything that's on that same VPC can talk directly to the pods. They don't have to use node ports. They don't have to do any sort of fancy routing, kind of going through hops on a node. It is not a thing that's specific to GKE. There are plenty of other CNI providers that can provide this. You want this, right? This opens a lot of doors for you. Most of the things that I'm going to talk about require this. You can see it's a building block for Google's internal and external latest and greatest load balancers. Traffic Director requires this, multi-cluster services, MultiClusterIngress. Service Mesh doesn't technically require it, but most of the nice fancy features in it are going to require it. So just keep this in the back of your mind. Something that you really want to make sure is whatever Kubernetes you're using, don't have overlays, don't have these kind of boundaries that prevent you from being able to access those pods. It kind of just gets in your way. And nowadays, you don't need it. Node ports, they're still useful in very specific circumstances, but for getting traffic to your pods, hopefully you don't need to use them. So, the next I'm going to talk about is something we call fleets. So, the way to think of this is it's kind of like the Apple ecosystem. I'm going to show you a lot of things that are a vertically integrated stack. And it's a walled garden in some sense, but it enables them to work much closer together, right? It's a vertically integrated stack of a service mesh, of tools for managing your workloads, the networking inside of it, and all the things we're going to talk about there. It's vertically integrated. So for fleets, it used to be called environs, and it's a way of thinking about namespaces across clusters, right? These clusters should be managed by a single team. It's not like those 3 different teams that I was talking about. Those would be 3 different fleets usually. But the infra team might manage hundreds of clusters, and if there's a prod auth namespace in that cluster, it's going to look and operate just like a prod auth namespace in another cluster. We're going to do things like connecting the service mesh together. You're going to have an identity that is the same across all of those clusters, right? And so this is just our way of trying to kind of paper over some of those problems and say, well, just put it in a fleet, make sure that you don't have to have all, it doesn't have to be exactly uniform. You might only have your auth name service in a few of your clusters, but if you do and it's in that same namespace, it should act as if it was in any others. You kind of map this onto like a Gitops approach, right? And manage your resources in Gitops YAML, and if it exists, you apply it, and maybe you have some lightweight customized style actions, but it really should be, you know, a way of just thinking of things operating in a very similar manner. So with those two things, we're going to be able to provide some very nice features like MultiClusterIngress. This is essentially just a Google Cloud external HTTPS load balancer, but it isn't tied to a single cluster or even a single workload, right? Instead, you actually have a CRD called MultiClusterIngress, and you apply that into, we'll call it a config cluster, but it could just be one of your preferred workload clusters. And from that, you get an Anycast IP, right? Just like you would on any other global load balancer. They're really nice, they're really great, actually operate a lot like a CDN or a POP. But you'll be able to configure it and say, oh, I want these front-end services to be mapped to this global load balancer. And it instead of having to use DNS to do that routing, which DNS works, a lot of things are built around DNS, but this gets to operate as it has better health tracking than DNS does. DNS has TTLs and all this stuff. You don't really get to control much. This you get to control the front door. You get to program that external load balancer via the MultiClusterIngress CRD. It's built on the back end using NEGs. If you've looked into any of the GKE or GCP load balancers, it's just a NEG. And it just kind of helps you build that up. So we replace the DNS part with MultiClusterIngress. Great.
You create.
Go for it.
Is making that ingress that like making a load balancer? Or is it like an ingress rule? How many of those do you make? Just one?
Yeah. So it is essentially if you took the existing Ingress spec or more closely something a little more flavorful than the existing Ingress spec and moved it up and then kind of got to control additional backends, right? If you've used Traffic Director, it looks a lot like it probably actually is Traffic Director under the covers.
Yeah. So you're not making the load balancer, you're making the configuration rules for the load balance, all the magic above it.
Correct, and you would get to specify from the load balancer view what the backends are, right? So you'll get the negs kind of get created by GKE, and then your CRD points to the neg, and that's kind of how it wires it up. So this is not the most expressive version of how to do this, but it is the simplest version how to do this.
Is it a config connector resource?
Config connector resource. So it is a Kubernetes KRM resource. It operates very, very similar to a config sync or config connector resource, but it's closer to the Kubernetes side than just a YAML representation of a load balancer, right? So it kind of splits the difference a little bit there, if that makes sense.
Is it an external API in Kubernetes? Like how is it actually implemented? It's
So,
not GKE, it's a...
the fleets give GKE a place to run global controllers, right? So at the end of the day, it's a Go code controller programming against the existing GCLB APIs using YAML or protos that are specific for this, if that makes sense.
Is this only Anthos?
It started as an Anthos-based offering. My understanding is it has now been separated out. So if you are paying for Anthos, which is a requirement for fleets and some other things, this is covered under the Anthos license, but you can license it separately as well. That is something that I think they implemented like last half of last year. So they recognize people didn't like the cost of the full up Anthos license. My opinion is, especially for this and some of the other things we'll talk about, if you're not using that whole stack or most of that stack, maybe you have your own flavor of Gitops that you prefer, but if you're not using that whole Anthos thing, there's probably better solutions that are at least coming soon, if not already available, and like, market-based offerings. This, I don't think this CRD is something that's like kind of an upstream open source thing. One of the others that we'll talk about is. But it definitely works better. Like, it's that the Apple ecosystem of like, that's vertically integrated thing. If you buy all into it, it's gonna be nice, easy.
And this is, so I feel like I've heard you say in a multi-cluster world, you wouldn't create a regional cluster. You would prefer zonal clusters.
So that is one reason to have multiple clusters. So you should never create zonal clusters unless it's for your QA or dev environment and you want to save whatever the extra cost is. They have no SLA. You should always use regional clusters. But if you want to control your cost of zonal egress, you could have 3 regional clusters that just have node pools within one zone. One reason to do it. And then this thing could sit in front of it and make it look like your old cluster of 3 node pools did. And now once something enters the cluster, you can get a lot more guarantees about it never leaving that zone versus until there's topology, aware routing or hints or whatever it is. That's kind of a, but yes, this would be one way of solving that. And we'll see some more. So what we really want to do is get rid of those load balancers, right? Like all that stuff inside the cluster, we still had to put the way to get rid of those services, right? So this is a new upstream KEP that builds on top of the existing service resource to say you can have a service that gets exported and then a cluster that will import that service, right? And basically all it's doing is taking those endpoint information and passing them between clusters, and in this case, passing them along to a control plane that can program a neg that can then do XYZ. Or in this case, it's actually using the existing control plane inside of the cluster, and instead of just having a cluster IP, you can have a cluster set IP. Right? And so you would get the exact same DNS-based service discovery that once a cluster imports a service, when you use that magic DNS name, it's just going to land on the exact pod IPs that are a composite of the healthy endpoints. And through the magic of, routing, you just land on the pods, right? So this doesn't involve a service mesh. This is Kubernetes native DNS discovery extended to be multi-cluster, which is really nice, right? You no longer have to worry about your Envoy proxies and your whole data plane service mesh stuff. There are definitely ways of doing this with that, but if you haven't jumped into that world yet, this is a way, kind of more Kubernetes native way of doing it.
Would you still have like, here's my designated config cluster where you create the service and everyone imports from that?
So I think this does require a config cluster. Most of the time that just means you pick a primary. If that cluster were to go away, I don't think it has huge ramifications. Maybe it does. Maybe the controller that keeps the negs updated, so you'd get stale data. Yeah. It's like you could have a stale, set of endpoints. I do think it requires you to do a primary. We usually recommend that it is just a third cluster you spin up and does nothing but like global stuff, like you don't have workloads in it. But if you're cost conscious, a lot of the edge stuff that we've been implementing tries to collapse it down and not have quite as many. But it's really cool, like this stuff being pushed through the open source Kubernetes KEP workflow means a lot of people look into it. It's likely to get a lot more adoption. There was a company called Submariner, I believe, that was doing this before, and they were also solving the data plane issue of like, maybe you got clusters here and there, and they can't talk to each other, and let's poke some VPN holes and do all this stuff. And they had some great solutions when you have that problem. If you can live in a world where you can talk to other cluster pods directly, this is just a nice kind of more elegant way of being able to do that.
Is this all within the same VPC?
So this does require, currently, I believe, a shared VPC, and in some cases, even within the same project. Those are the kinds of things that are currently blockers that we would hope to get rid of. There's no reason why it couldn't do it. It's just how the current stuff is all wired up. Sometimes says, we can't have, I think for the existing load balancers, they couldn't do cross-project. So this is just the Ingress side, the MultiClusterIngress is using the existing external load balancer, and if that can't do cross-project, this definitely can't. But they're working through, that's on a list somewhere that blocks some customer and hopes to be removed in the future. But yeah, most of these are kind of assuming the data plane problem is solved and that you can talk to it. And the firewalls, I think I think at least in fleets, they also are assuming that like once you're in a fleet, they're trying to elevate the guarantees of the pod network that are provided by Kubernetes get elevated up to the multi-cluster version of that, where like pods have to be able to talk to pods. That's what Kubernetes says, and so we try to build the same thing on a multi-cluster basis. Yeah, I haven't seen others that are using this yet, but I wouldn't at all be surprised to start seeing ServiceImport, ServiceExport being used in other Ingress controllers as well. What if we didn't need any of those either? What if you could just take that amazing Kubernetes service discovery built around DNS and just offer it to other clusters or even other VMs in your VPC? Well, Cloud DNS for GKE is a way to just get rid of kube DNS, get rid of core DNS, and just use the DNS provider that's built into a VPC. You can either have it be cluster scoped, meaning it still only works inside of the cluster like it previously did when you were using kube DNS, or you can have it be VPC scoped. So if you set this as VPC scoped, you can have two clusters, one in the US and one in Europe. And you register those with, instead of the cluster.local suffix, you can give it, say, gke.us and gke.eu. And now, anything in that VPC, you can just ask, where is foo, bar, service, GKE, US? It's gonna get back all those pod IPs. And because it's container native VPC routing, they can talk to those pod IPs. There's some workloads that this is gonna work great for. Anything that was already using DNS-based multi-A record or sometimes SVC record lookups. Cassandra, Kafka, RabbitMQ, a lot of times they just kind of bootstrap themselves and then they'll announce to the world like, oh, actually use these endpoints. This works amazingly well for that. And you're back into as if this was one cluster, except now you're two clusters and whatever VMs in the VPC you want, right?
Is this available now, like
This
GA?
is available now. I want to say it GA'd last summer.
Okay.
There will be, so some of these, and I know update cycles are something you want to know what your SLA requirements are, because this might operate slower. It's definitely slower than things that were inside of a single cluster. This is across the globe, right? You could have things literally running across the globe on a single VPC. Most of the time, it's no worse than what DNS was before, right? This is using the exact same thing, but it's slower and maybe even an order of magnitude or two slower than what you were having inside a single cluster. That usually only matters when you're already hyper aware of your SLA requirements and doing crazy things anyways. This is one that I know of at least two different workloads that would have benefited from this immediately. And you no longer have to manage cluster DNS, which if you've ever had problems with that, that's a great thing to be able to get rid of. Yeah.
I assume this still doesn't have a way to solve like, I don't care about gke.eu or US. I just want foo.bar.service.
Bar.service.
Like, route me to whichever.
Yeah, they do require that they are unique when you register the clusters. I don't think you can have multiple. So like the other way I would try to do is just registering another one. But I don't think this solves that as well. And it is also the DNS base. So really the external global load balancers provide you the locality and fancy routing stuff that solve that problem better than DNS does. This really is just like, I just need to talk to a pod. The pod's gonna tell me the rest of the information and be on its way. So you're kind of relying on smarter client servers when you're using this.
Well, yeah, what you pointed out here specifically goes with all the things that use stateful sets, where you get like per pod host names, and you're like, I need to talk to Kafka broker 2, wherever that is. That's the trickiest part to solve the Kafka.
If you've ever tried to run Cassandra or Kafka inside a cluster and you're like, this is amazing, and then somebody's like, I'm outside the cluster, how can I use it? And you're like,
You can't.
you can't. This solves that more than the wider problem. We have better tools for that one. So. Okay. So, back to exactly what you were just saying. So how does it look on MultiClusterIngress? Well, latency, shortest path, any cache routing, right? Orbit, this is why they got bought, right? Like this is what they were able to provide, is that CDN-like experience, but in a fancier way. This is no different than the normal global load balancer, so there's actually nothing too crazy about this other than it can do routing around a cluster failure, right? So your client talks to the local POP in Utah. It's actually just up here in South Jordan. That's where you get terminated TLS. And then you're on the Google backbone and get routed to whatever the closest, healthiest cluster backend would be. So that kind of zonal regional failovers are what that is specifically trying to address. But then there is, more advanced traffic management that it can also play a part in. So things like migrating between clusters. Maybe you want to do a roll from one to the other. Controlled manner. Waterfall, canary, traffic shifting, these are all common things that you've probably seen in service meshes. That kind of blue-green multi-step deployments, they get kind of complicated sometimes. So this is like the full state section of a 6-way failover, and you can do evaluations between like, oh, can it automatically go back? Well, this is, tries to make some of those use cases very, very easy. I would say by the time you're doing this, you're probably approaching the level that you want a tool that either gives you more control, and like, the reason I don't use iPhone is its way of doing things is often different from my way of doing things. You're probably gonna experience that at the edges of this kind of stuff. But all you need is simple blue-greens or simple.
Why did you add colors?
These aren't my slide, these are just, I just copied a whole bunch of stuff, so.
So for this specifically,
Supposed to be simplified.
you also have to run like the GKE Ingress, or can it be any Ingress?
So this is assuming you would use MultiClusterIngress so that you can program the information at the global level. If you used the built-in Google Cloud Load Balancer Ingress controller, you would get this inside a single cluster.
But I'm saying if you have the multi-Ingress, is it a requirement?
So there isn't multiple tiers, if that's what you're asking, right? So like previously I have seen you do a DNS load balancing and then you do it to an Anycast that then does a tier 2 that then hits a cluster, and inside the cluster does an Nginx and all that. This is assuming just one tier, right? You have one resource that programs at a global level that knows all the pods and can do all the routing.
So there is no per cluster Ingress. It is straight to pod.
It is an external global load balancer talking directly to pods in your cluster. No intermediary between there. You could, if you had business logic in Nginx and you wanted to keep that in, you could still do that. But this will allow you to go directly down to a pod, which is nice because if you're wanting to remove latency or those multi-tiered things, oftentimes what ends up happening is when you hit a scale limit, something breaks, but you don't know where in that chain it breaks. In this case, there's nothing to break because it's a load balancer to pod, which is really nice. Waterfall was a really cool one. So let's say you had clusters in multiple areas and it was primarily because of cost. You get a great rate in central, but you wanted to overflow or have HADR in another area. And so you can actually program these to include max rates. So when you start with 40 RPS, everything goes to GKE US. When you trip over the max rate for that cluster, it would start waterfalling into Canada. And then you could have it waterfall into Europe as well. So this is something that has been available in the external load balancers. Like this is a traffic director style feature, but it wasn't very easy to program it into GKE. And then it's these kinds of resources that are going to allow you to get what are more advanced features that native load balancers haven't had, but are starting to get. So that's really cool. And I actually haven't seen anybody use this because it is a very specific case, but I can envision why someone might want to use it. So I know what you're saying. That's cool. What about my service mesh? So maybe you are like a big Istio shop, right?
I was not saying that.
It's a rhetorical, yeah.
Then you'd be like, but what about my crypto? We would all shit on it.
So Istio's great, but it's also really complex, right? And there's a lot of things in there that you do get a benefit from if you just say, I want somebody else to manage that for me. I want a vertically integrated application of the service mesh. I want somebody else to make decisions, vet the binaries, do the upgrade testing, and have support for it. So that's ASM. It is Istio. It integrates with telemetry. It gives you the managed CA. It does stuff with traffic directors, so some of this splitting and canarying and circuit breakers. If you want that inside a cluster in a service mesh, it'll do this. The mapping, if you're familiar with open source Istio, there's all the components that they've even recently shuffled. You kind of offload a lot of those, right? And you can even offload them outside the cluster. So it's not just running a Google version of Istio-D in your cluster or Mixer or any of those. Like you can actually even pull them completely outside your cluster, which when you start talking multi-cluster, you always have to do this like, well, where does this thing run? And you sometimes have this crazy, like, we'll just have the config cluster and shove it there. In this case, you could just run it on Borg. Right? You get managed Istio outside the cluster using a mesh CA, so your entire multi-cluster setup uses the same CA. It's all signed and TLS just works. Like this can all be done in open source Istio, but it's not fun. Like it's really easy to screw this stuff up, and it's even easier to have it screw up when you're doing an upgrade cycle or something changes. And so there's going to be more and more things in the future that if you use ASM, you'll get the benefit of access to those. If you're using Istio, maybe you won't, maybe you will, but you'll have to do a lot of work yourself. Just mentioning that's part of this fleet and kind of walled garden per se that we're building up. So this doc here is actually, it would actually work exactly the same using ASM, or if you program the mesh yourself to actually be multi-cluster, just kind of showing how that looks from the cluster side. So you get the same, DNS lookup, right? You land on an external load balancer, whatever the closest one to you is, that's healthy. There's a path to your Ingress gateway. If that isn't working, then it would route you to the healthy next closest to you. Once you're inside the cluster, that Ingress gateway, just like the mesh usually does, it will route you to the front end, but if that isn't healthy, it can route you to the one on the other cluster. You just kind of get what you would expect from this if it all works, or when things break, you can route around them. So actually haven't worked anywhere that has had a multi-cluster mesh. It sounds like a nightmare to me, but if it's something that you want, ASM is a great way to kind of lift at least some of that burden. And I would probably prefer the container native approach, just because I know service meshes get pretty complicated, but if you're all in on that world,
Are there more version like parity requirements between the clusters at that point? Like, seems like there's got to be a lot more line. They've got to be pretty much uniform for.
Yeah, it's about the same as when you're doing rolling upgrades, right? And so I think they're They're allowing one minor back. So you can do an in-place upgrade staggered. And this is about the same. You're just having two, like you'll upgrade one cluster and then the other, and they can't drift too much.
Okay.
Like I said, I've never actually done that, and I know there are people that are. So gateway controller, this came up today, and it is a better way of doing Ingress, right? So Ingress it was great when it came out, and in the time that it came out. It has had a lot of adoption. It has a lot of different controllers that can use it. And it is a pretty straightforward and easy to understand. But it is not very expressive. It is basically the lowest common denominator of Ingress. It is incredibly difficult to extend without just turning everything into an annotation. It doesn't actually have portability very much. And if you ever try to program these with Gitops, like it can be a nightmare pretty quickly, right? So Gateway API is very early on, but it is going to allow you to do things that things like Convoy or Contour and more advanced versions of these features. And if you look at it, it really just looks like Envoy and Istio specs, and really like they're consolidating down into a more expressive version of these things,
I
right?
was gonna say, it's more readable than an Envoy spec,
Yeah,
which is a low bar.
that's
but-
true. Yeah, that's true. I've seen filters show up in some of these, and so like you still get some of, yeah.
Everything's a foot gun.
What basically ends up happening is when you get into the weeds of the complexity, like it's complex, right? So you can't get rid of that. But it's also had a lot of adoption for being this early. This thing landed, I think 121, 120-ish. Like it's been in the works for a while, but there's 8+ implementations of it, right? Pick your favorite Ingress, go find what they're doing on this front, hammer at it, and in another year or two, hopefully you'll be able to use it, right? And then if that one breaks, you pick another one, and you don't have to refactor everything and redo all your CRDs and do the custom version of this and the custom version of that. It's hoping to be a lot more expressive and standard way of doing this. Just like CNIs and some of those have kind of,
Where's
benefited.
Contour?
Red Hat.
It isn't on there. It's the, one of the, that URL they listed. I think
I
there's,
think they're actually VMware.
Yeah, I know they got bought by one of those two. I can't remember which.
All right, fine.
the musical
You
chairs.
get it passed today.
Yeah,
Like I
well,
said, not my slide. I just stole some more.
Are these all somebody else's slides?
Yes.
Oh my
A
goodness.
lot of slides that I have access
Is it
to.
even your talk?
No, it's actually somebody else's that I was like, that's good. I want to. But so the differences, right? So it used to be that service owners themselves created the Ingress resources, right? That was pretty much all that you could do. Works great until you're scaling and having a bunch of, and like there's a better separation of concerns that you can have there, which is you're on a platform, right? You're running on some cloud or even bare metal setup, and the platform should provide the gateway class, the actual like, this is the thing we're going to use. That's the gateway class. The platform administrator, the teams that are running the infrastructure can say, all right, we're gonna make one of these gateways, or maybe we're gonna make one of these gateways for this team and another one for that team, and have the actual external load balancers that are gonna be popped into existence. And then the service owners can just attach routes and services to those, right? Your data team might have 25 different host names they use and a bunch of different paths on those. They don't need 25 different load balancers. That should all be one with host header-based load balancers and all the route traffics and all of that. So that was the kind of thing that when you got to that, lots of teams doing lots of stuff, really caused problems on the old Ingress resources. And this tries to make that more uniform of platforms do this, the Kubernetes cluster administrators do their part, and then the service owners are back to being able to do what they cared about, which is just creating their routes and attaching the services to them.
creating one isn't the hard part. It's actually, like, having one big gateway is usually easy. It's when you need, as soon as you have two, and then you're trying to like coordinate which services go in through which gate, like having more than one giant one becomes almost impossible.
Yeah,
They also get coupled, like if you, I've run 2 traffic ingresses, one for internal, one for external because of old like VPN networking stuff, and like, it was really easy to just say like, just use this class or that class, but then it was like, oh, you're tied to the internal class and you cannot, I can't add a third without you being coupled to that one instead. This sucks.
What's even more fun is if you remember the days of editing Nginx configs, you can slap raw config into an Nginx ingress resource.
Yep.
Guess what happens when that config isn't correct? The entire thing stops updating.
Again, one of its
It's
many.
stale data, and eventually your pods just start falling out of, like, their IPs change, and eventually the whole thing stops working. You're like, oh, the ingress for this entire cluster stopped working because that team made a config change. Nice.
Or somebody
Typo.
wants the root URL.
And then you learn how to make an alert. The validating hook and all that, like, yeah.
Yeah.
But I've been through that.
Create Anchors folders for root.
This is just more of the same, so internal, external load balancers, host path, database routing. You have an installation of this, that's a very common thing that is now baked into default
Where's
resource.
the TLS termination defined? Is that at the gateway or the ingress?
So it's up to the implementation for Google Cloud. TLS is always terminated at the edge pop. So it doesn't even have to be a region. There's edge pops like a global CDN network would have. There's, I think, 300, 500, something like that. And then that's where things get terminated at like the front end, and then it traverses back to the actual cluster. So TLS termination, it probably does multiple, but you care usually about the client. And so like your client talks to a POP, terminates TLS. From there, it does another session of TLS.
I guess, is that part of the gateway spec or is it part of the, go back to your previous slide?
There is, I want to say, inside the HTTP route, there are sections for managing TLS.
Okay.
So if you needed to say attach a specific cert, it's more than just an annotation, which is what it used to be managed by. There's actual like first class TLS cert management as a part of this. But yeah, definitely look at the HTTP route spec, and I think it's just an attribute on there.
Okay.
Is that like a new ingress controller? When you say gateway
This is it,
controller?
yes. So you no longer use ingress resources, you use gateway resources, and it's managed by a gateway controller. And the hope is that you can define those, and maybe you use Google's, maybe you use Kong, maybe you use Contours. You don't really have to care much. Your platform team to decide that. They decide what gateway class you're using in your cluster for your gateway. And then the rest of it is just like, yeah, they just make their routes and their service attached to it, and they're on their way. And if your platform team decides to change, you could change it out from underneath and they wouldn't even hopefully have to notice.
Did you read the, you didn't read the link today in Slack? It was describing what the gateway interface spec was and all.
Yeah, no, I've read that before.
Okay.
Yeah, there's a good video.
I'm more curious, is the GKE ingress controller deprecated in favor of?
Deprecated, no.
No, not officially.
Superseded, yes.
Superseded equals deprecated in Google.
No.
When do the
No.
ingress resources?
I mean, so-
Fair enough.
So deprecation means the API is no longer available, right? HTTP ingress beta 1, no longer available. You have to change your resource to be GA whatever, networking GA whatever they made, right? That won't go away. I doubt that will ever go away because it's the lowest common denominator and has had such wide adoption that it'd be foolish to get rid of it. It's just code that will stagnate there and hopefully not have security vulnerabilities, right? This is a more expressive way. So what hopefully gets deprecated is the custom resource defined by Contour and the custom resource defined by Kong.
In traffic.
Sorry, I think I'm not being clear. I'm looking at this thing that says like Cloud CDN, and if you don't use the the GKE ingress controller, you can't do Cloud CDN.
So just like you can have different ingress classes right? Gateway class is the same as Ingress class. You can have Nginx, Kong, Contour, all of those in your cluster, and you annotate your resource to be, I'm this class, go use that controller. You can do the exact same thing with gateway, right? I can have the Google Cloud Load Balancer gateway controller right next to the Kong gateway controller, right next to the Istio gateway controller.
I think the goal is that HTTP routes now can describe just about everything you might need to describe, whereas Ingress can do almost nothing.
So I'm talking about the actual Google resource.
Right,
Like,
well,
Yeah.
but,
check GC Ingress controller.
Stop talking Kubernetes for a moment, because he's not talking about that.
TCP route.
No.
He's talking about if I have like the GCE VM and a Google load balancer, that's required for using Google CDN.
yeah, no,
So where does that
what
fit
I'm saying
into
is the
this?
HTTP route stuff is the minimum promises, but depending on the gateway that you choose, it may go above the minimum promises, right? So you might be able
It's designed to be extended, right? So they call it core, expansive and something, like there's different layers on this and like the core thing is the default. But if we want to attach a CDN to this, there's a well-defined path to do so, right? Whereas previously it's like slap annotations here, there, everywhere.
Right. So if you can go to the next slide, I guess I'm just asking, that GKE gateway controller, is that like a checkbox I have to add on to my?
That's something that will be running inside your cluster, just like the previous Google Cloud
Right.
Ingress controller
Okay,
was.
yeah, that's what I was
But
asking.
it will be alongside it. Like, we're not getting rid of one or the other. You're not gonna have to enable it. This is baked into all of the common cloud provider controllers that you just get when you run GKE.
Right. The GCE one is so limited, and I'm wondering if this one will be better. is
This one
the
will
main
be,
thrust of my question.
the design is to be feature parity with anything you could do using the Google Cloud Load Balancer API directly. So like Traffic Director, this thing should be feature parity with Traffic Director at some point, which is crazy, right? Like that's a lot of stuff.
That's cool. 'Cause yeah, I've always been disappointed by the original.
It's really cool, and so the thing is this is alpha right now. It's hoping to go beta very soon, and I think even GA this year. So like it's on a pretty fast track. It's why if you care about this stuff, use it. Because if it doesn't have your feature now, you can say, oh, why can't it do this? And hopefully it's on the roadmap, or they'll put it on the roadmap. And in 18 months, I'm hoping that just everybody's using this because it has everything you need. And that would have solved tons of problems at Reddit too, right? And yeah, so it's all native. It's just, I don't know what all these boxes are. External multi-cluster, internal multi-cluster. It is basically just providing a single spec that we hope covers 95% of use cases and gets you to feature parity with what Google Cloud can provide, but then also lets you hop between them much, much, much easier than what is pretty miserable right now if you've ever tried. Like if you've ever tried to turn an Nginx config to an HA proxy config to a Trafic, like you just won't even try. You would just be like, oh, well, it looks like it's doing this. Let's make sure we set the same headers, and you'll miss stuff.
even the most trivial one of like the GKE Ingress, like the standard one you're talking about, like it has to be a /star. You put that in Nginx /star, it all falls apart because that's the path prefix, not a matcher. Like even the most basic, like everything at this host falls apart with normal ingress between two providers 99% of the time. Like it just not descriptive enough.
When we were doing Nginx, when we found out it was working almost by accident, because we were annotating it with Cert Manager and external DNS, and it was just slapping them together in whatever random order. And so we would have 7 certs or 10 certs for the same API.nozzle.
Yeah.
So
I would just pick one.
I will definitely say, I mean, it sounds nice and warm and fuzzy. There are a lot of fine details on these. Like, it's crazy looking through these lists of like, so here's external ingress, internal ingress, and then the multi-cluster ingress, and they all have their own, like, I can do this, but not this, and you should think about that, and you're gonna run into the hope is that over time, things get more and more uniform, and stop varying as much. So this is the gateway controller. There is regional internal load balancer, regional internal multi-cluster load balancer, global external load balancer, global external multi-cluster load balancer. And there are differences between those that when you put in a support ticket saying, why can't I do this? They'll point you back somewhere on this page and be like, oh, we actually said. I'm like, okay. But hopefully over time, they'll go away and some of those will just become easier to use. So definitely lots of stuff. Oh, this was the service mesh one. This is super interesting. So you were mentioning versions. How up to date are you on your Istio, right? Like it aggressively ends of life Istio. Like they're only gonna do a couple versions forward and back, and then at some point, either you go out of support or I don't think they force upgrade on ASM, but you can't just run Istio 1.8 forever, right? Like that's
That's not surprising managed service that.
well, I've been places that have run very old versions of Istio because it was way too difficult to try updating a dozen clusters and like.
Oh, well, yeah, but they weren't using a managed, I doesn't make, it's no surprise that GKE would say, you gotta stay in line.
So that's just about, that's all the main material that I had. I was trying to go through a demo, about 35 steps, and at the end, you get an HTTP request that says like green or blue or east or what. It wasn't really worth it, so.
I'm curious on as it's creating all these, the new like NEGs and all, like, is there a cost difference for doing the fancy Google pod to pod load balancing versus?
I don't think container native load balancing costs anything. It's a change on cluster. And there are costs for ASM. I believe it's per point that they license. MultiClusterIngress has a licensing fee similar to if you were using an external load balancer or maybe attaching CloudArmor or doing a CDN in front of it, right? It's kind of like, you could think of it like a premium load balancer. Fleets and the rest of Anthos has costs. They try to bundle a lot of it into just buy an Anthos license and you get the Apple ecosystem of features. I will also say they've changed it 3 times already. I wouldn't be surprised to see it change 2 more. And it's the kind of thing that they want people to use. So if pricing's the problem, just talk to your reps and say pricing's the problem, and sometimes it goes away, but, or at least gets better.
I have many questions. I'm sure that's shocking to everybody. On how does this like play with, there's cloud endpoints, there's API gateway that's Envoy based, there's Apogee, there's an Apogee Lite coming.
So just like that Envoy won the data plane war, most of this is built on Envoy. And so at the end of the day, Traffic Director is a way that you can manage things from outside of clusters into whatever the workload is. ASM is a way you can manage it from a cluster out. Those kind of converge over time. They all have their unique flavor. So API Gateway is a feature for people that needed to have a way to compose APIs. Apogee is the very large version of that. That's like you can license it, monetize it, split it between 5 teams, have 4 like it's the super advanced version of it. Outside of those 2 things, most of what this comes down to is some flavor of XDS programming Envoy running somewhere, and you're starting to split hairs when you point at all the different, especially like between MultiClusterIngress and the gateway class. I can't even figure out the difference between some of those. Like, is this just different ways of using Traffic Director to create a neg to attach to a load balance? Probably, right? It gets very fine, nuanced. But what does end up happening is, so like Apogee now uses Apogee X so that they can run inside of a cluster, and you don't have this like bounce between 5 things problem, which this tries to help and tries to solve, but those are still hops. And there are reasons why you might just want to run this in a cluster, or you use glue instead. You have better control over that Envoy instance in your cluster, which is always what it is. It's Envoy somewhere. And if it's not Envoy, you should why it isn't. Because what's crazy to me is, so Nginx was like the load-bearing data plane for the 90s and 2000s, and I don't think it is anymore.
I think
Envoy's,
it was the 90s.
that was Apache, sorry.
Yeah.
Apache until like 2006-ish.
Apache had a good decade, and then on Nginx, and I've used, a bunch of places I've been had HA proxy, but I've never used HA proxy's Kubernetes stuff because it was always for pay.
It's also not as feature rich usually. It's really fast.
Yeah, like, if I had to bet my job on a load balancer that, didn't need super fancy things and wasn't in Kubernetes, I would probably start with HA proxy.
So there's like the new V2 data plane on Cilium. How does that
Yeah, so
play into all of that?
Cilium is mainly aimed at replacing the IP table stuff. And the complication there is they're getting into a service mesh.
Right.
And I haven't figured out where their CNI ends and their service mesh starts. I do think the eBPF, the topology or hint stuff, I think that's actually part of the CNI. Data plane V2 is not their service mesh offering. It is a fork, but it's a variant of their CNI. And so I think when you're seeing stuff in Kubernetes that used to be managed by IP tables and the kube proxy, that's where data plane V2 replaces it with eBPF and Cilium.
Does Calico do eBPF as well?
Calico's started doing it too. The Anthos run everywhere, GKE, like we'll package GKE and put it on your VMware cluster, or we'll package it and you can run it on bare metal. They picked Cilium and the whole data plane V2 stuff as our data plane. It used to be Calico, I think. They saw good results, and I think eBPF is winning the programming kernel stuff war.
Yeah. Even way outside Kubernetes or cloud, yeah.
And so Cilium that would enforce like a network policy still magically makes its way into.
What used to be
I don't have to know.
Go code hitting IP table APIs is now Go code emitting eBPF into the kernel to do that same style stuff.
Again, if you're at the point where you need to like know all the details of this, you have a team that you pay very well to do this.
Or you would just pay for support from Google, and Google has a very good team that does this stuff incredibly well. It's amazing how
Google would be that team, yes.
Google's
If you're at the point where you're consistently using.
the funny thing is when we have to tell people you should go talk to ISOVariant, you should get support from them, because then they're doing some real crazy stuff if it's outside the scope of what we can support. And there is cool, like, the leading edge of Cilium is a cool thing to follow. Sure.
It's nice to not build on something that Google's gonna shut down.
No, they will.
I mean,
Jason and I had a call with the API Gateway PM.
building on Google Reader, what's going on?
I built my life on Google Reader.
No, API
and they pulled
Gateway.
it out from under me.
It just stopped. They stopped their changelog. And
So API Gateway is an issue. I've never understood why you would use that and not just write a mux and go. Like what benefit do you get out of API Gateway that you couldn't have just made a Go mux?
Well, they thought it was good enough
it's
to
like,
make the
because you
product.
can do like edge JSON transcoding that, right, in Envoy. It composes it all, and then your cluster can be gRPC only.
They had that in the Google Cloud API Gateway did
Yeah.
gRPC.
Yeah, you can upload your proto annotated,
Interesting, I didn't know they did that.
whatever the descriptor?
Descriptor file,
Yeah.
Probably the problem there was we bought Apogee.
Well, no, they're making an Apogee Lite, and API Gateway is going away, and that.
So this is something that's happened. It happened with Looker too. So like they had Data Studio and they bought Looker. So you spend a lot of money on a product that's like a premium, more complex version. The easy, simple version that nobody had to pay for starts kind of
That sounds greedy.
I mean,
Incorporate.
Well, but it sounds like it's not actually Apogee. It's just API gateway moving and being called Apogee Lite.
I don't think I've seen Apogee Lite. I'll have to go look.
So how
So,
many products are called Firebase something? Firebase did not build all those.
Cool. Thanks for letting me rant about multi-cluster networking.
Yay!
is anyone here doing multi-cluster networking?
Not like this.
I'm not even
I did all of it the hard way.
You're not even.
Just manually poking holes and running separate mesh CAs, and it was incredibly painful.
Multi-cluster networking between the software side and the phone sides.
I was stoked seeing that like you can now just like buy